Hi grade 8s, welcome back to another one of our video lessons. So today we're not going to carry on with the work in the textbook. We're going to go over some test revision. I'm going to tell you what's going to be covered in the test that you're going to be writing on Friday, and we'll run through these topics. Okay, so the test that I'm going to ask you to write is for term 1, okay, because we still haven't written our test 1 from before because we went into lockdown just before we were to write our maths test. So this test that you're going to write this Friday, this week, you're going to write on term 1's work. And then once we are back, we're going to go over some of this, we're going to go over this term's 2's work, and then we're going to write another test, another maths test for term 2. All right, guys, so let's start. I want you to take your textbooks, go to right to the beginning on page 4, which is whole numbers. And I'm going to go through section by section and tell you what is the important bits in each one and what you should know. All right, guys. So page 4, topic 1 is whole numbers. Okay, guys, so this is just understanding how numbers work. What are tens, what are units, what are hundreds, what are whole numbers, what are natural numbers, what are integers. Okay, you need to be able to tell me the difference. Okay, then on next page 5, we're looking at rounding off. Okay, guys, I'm going to give you another example of rounding off, but remember, rounding off always works the same way. So let's say we have a number 328.392. Okay, let's say that's what we have, and I ask you to, first question, round off to one decimal place. Okay, so whenever I ask you to round off to anything, the one decimal place, two decimal places, units, tens, hundreds, what you do is you go to that placeholder. Okay, so if I say one decimal place, there's the comma, therefore this is the first decimal place over here. So this is what I want to keep. Okay, in my final rounded off answer, I only want one decimal place to which I'm rounding off to. So what we do is we look at the next digit, not at the one that I'm asking about, but I'm asking, we look at the next one. Now, if this digit is 0, 1, 2, 3, or 4, we leave this digit the same. If this digit is 5, 6, 7, 8, or 9, which it is, we add one more to 4. So this answer is approximately 328.4. Okay. Now, you can see that 39 is a lot closer to 40 than it is to 30. That's why this becomes a 4. Now, another thing to note is that this equal sign is not a normal equal sign. It's a wavy equal sign, meaning that it's approximate value because this number does not equal to this number. We've chopped off a bit of it. Okay, so this is approximately. So in some of the questions, when it's not where I don't just give you a number and I say round off to one decimal place, I'll say, right, work out what is my weight in kilograms and round off to the nearest kilogram. So when you do your calculation, I want to see the answer. Let's say this was our answer from before, my weight in kilograms, right? Okay, I'm a bit too heavy here, but let's say it's something else. But anyway, so let's say I work it out. There's my actual answer. And then I round off the answer. So there's a mark for this answer. There's a mark for that answer. Okay. That is if I ask you to give me, like if I give you a word problem or a sum to do and then round off the final answer. Okay. All right, guys, let's do another example. Let's round off this to two decimal places. So I go to my second decimal place. There it is. I look at the next digit. That's a 2. Does that add one more? No, it does not. So if we want to round off this to two decimal places, this will approximately be 328.39 because the 2 wouldn't add to the 9. Okay, guys, the same thing works for units, tens, and hundreds. I could say to you, round off this value to the nearest units, okay? Here's my units. Go to the next digit. It's a 3. Does it add one more? No. Okay. Cool, guys, that's rounding off. It's always the same. The procedure is the same thing. Find the digits that you're going to and then round it off. Okay. Guys, I'm not going to ask you to round off to the nearest fives. I know some textbooks do that. I don't like that, so we'll round off to only in tens, hundreds, and so on. Okay. Right, properties of whole numbers. So guys, you need to know how to add, subtract, divide, multiply. Okay, long division, long multiplication, that's all algebra. I can definitely ask you to show me how to work that out. Okay, and you have to show me all the workings, guys. Please don't use Photomaths. All right, like the grade 9s do. Okay, so let's continue. BODMAS, remember the order of operations. Okay, so what is the order of what we do? So B is for brackets, of, or O is for multiplication. Then we have multiplication, division, addition, subtraction. Okay, right, let's continue. So that is page 8 and 9. Okay, multiples and factors. Guys, we've done this plenty of examples. So we have highest common factor, HCF, and we have the lowest common multiple. Okay, remember how those two work. How do we do that? We take our number using our ladder method, we break it up into our prime factors, and then we take the ones that are common, which is the highest common factor, and the ones where they appear the most is your lowest common multiple. Guys, please go over these examples again and make sure you know how to do this. Right, solving word problems usually involves speed, distance, and time triangle, so you must know how that works. Okay. Right, then we have some discounts and VAT, so some percentages, hire purchase. Okay, we've gone through these examples. Budgets, exercise 1.6, have a look at that. Also ratios. Guys, remember how ratios work. I can ask you to write a ratio in its simplified form. So let's say I give you 2 to 4. Right? What is the simplified form here? Well, we want to divide by a common factor here. So we divide by 2, divide by 2. We get 1, which is equivalent to 2. So this is a simplified ratio. That's not. Remember, we stop once we get these two to our prime numbers, so to speak. So you don't want to go into the decimals here. You don't want to say 0.5 to 1. Okay. All right, so let's continue. Then we have page 18 in integers. So remember, integers are whole numbers, positive and negative, including 0. Okay. Then we got page 2021, doing calculations with integers. Okay, so remember plus and minus. How do we, when we multiply signs, when we're not multiplying signs? Okay, more BODMAS operations over here. All right. Okay, multiplying, dividing integers, the same thing. Remember, guys, it's the same as multiplying numbers as we did before. It's just now you need to pay attention to when you're multiplying the signs. Okay. Positive times a positive is a positive, negative times a negative is a positive, and positive times negative and vice versa is always a negative. Okay. Right, guys, so let's continue. Then we have page 26, 27, solving problems with integers. All right, so it's the same thing as what we've done before. Now we have integers, which means the numbers can be negative, like a negative 2 squared. How do we do that? Okay. Okay, guys, let's continue. Financial calculations. Okay, so that's page 28. Remember, you want to give me the rand sign at the end of the example. All right, let's continue. Then on page 32, we have exponents. Remember how exponents work and the powers. Okay, so if I have 2 times 2 times 2, that is 2 to the power of 3. Okay, and then the reverse operation is going to be our square root and our cube roots. Okay, so remember how to go forward and how to go backwards. Okay, it's almost like inverse operation. So if I have x squared, to get rid of the square, I'm going to square root both sides. Okay, all right, guys, that is page 34, 35. Okay, 36, 37 gives you more examples of our square roots. Okay, guys, remember this kind of square root. So if I, or rather a cube root, if I have a cube root of 0.008. Okay, guys, the trick with this is to look at what kind of root am I taking. I'm taking a cube root. Then you're looking at, well, what is the number here? The number here is 8. Forget about all these zeros. So what is a cube root of 8? We know that is a 2. Okay. But now we have 3 decimal places. So remember, where did this number 0.008 come from? It came from cubing some other number. How do we get 3 decimal places? That's when we multiply, let's say 0.1 times 0.1 times 0.1 gives us 1 times 1 times 1 is 1. 1, 2, 3 decimal places, so we need a 0, 0, or 0.001. So what I'm trying to say here is that count how many decimal places we have and divide that by the kind of root that we have. So 3 decimal places divided by 3 means that each number is going to have 1 decimal place. So the answer here is 0.2. Okay, and we can test it. 0.2 times 0.2 times 0.2 is going to be 0.08, just like this is 0.01. Okay, guys, so it's not a very complicated trick, but you have to keep that in mind. And then remember with the negative as well, we could have a cube root of a negative. If there's a cube root of a negative, the answer will be negative, because negative times a negative would be a positive, times a negative again would be a negative. Okay. All right, guys, so that's exercise 3.2. Okay, then on page 38, 39, we have some rules for exponents. Okay, so guys, I suggest you learn these rules and you understand how they work. Okay, because you're going to be applying them in the problems that I'm going to ask you to do. Okay. Right, so the few rules that you need to know, there's 3 rules and a product rule. Okay, let's continue. Right, page 41 is scientific notation. Okay, so remember, we go from scientific to normal to decimal notation and then backwards. Okay, so guys, this is very, very easy. Let's quickly go over an example. So the formula is a times 10 to the power of n. Okay, so a is known as the significant, okay, and it's always a number between 1 and 9. So we don't want a 2-digit number there. Okay, so how are we going to do this, right? Let's do an example in the book. So I'm on page 41. So they say write 4.7 times 10 to the 8 in scientific notation. All right, no, wait, hold on. Write 4.7, which is written in scientific notation, in decimal notation. Okay, so we need to write this in decimal notation. So this equals to 4.7, okay? But now we're multiplying by 10 to the 8. So we're moving this. Remember, we count the zeros. So 10 times 10 times 10 will give you 8 zeros. So we're moving this comma 8 places to the right. So it's 1, 2, 3, 4, 5, 6, 7, 8. The comma goes there, and this is all zeros. Okay. And then we can remove that. If you guys want to do this in a test, use a pencil. You can leave the pencil marks there. So now this would be written in decimal notation. This is scientific notation, that's decimal notation. Right, now let's go backwards, okay? How do we go from this number to scientific notation? Well, we do exactly the same thing. We go to the number, to the end of the number, and we bring back the comma up to 1 digit because we want to have a significant that's between 1 and 9, okay? So we only want to keep 4 and then comma 7, so like this. So we need to put a comma here. How many places is that? Well, 1, 2, 3, 4, 5, 6, 7, 8. So this will equal to 4.7 times 10 to the 8. Okay, just like what we have on top. Okay, guys, so that's how you go back and forth. We can also do the same thing with very small numbers. So we can write small numbers in scientific notation as well. All right. So let's look at that. Actually, guys, they don't do small numbers. That's grade 9, so it's quite lucky for you. So you're just going to do that. All right, guys, so that's page 42. 43 is your revision. Okay, and then page 44, 45 is going to be our numeric and geometric patterns. Remember the formula that I showed you? Tn equals A plus n minus 1 in brackets times D. Okay, guys, I definitely want you to go over these questions and practice these formulas again. Okay, remember how we found the general rule for any term? It was finding the A, finding the D, putting it all together. Now remember, not all patterns are going to be numeric patterns where we're adding or subtracting the same thing. We could be multiplying by the same thing, or we could be doing squares or cubes or something else. Okay, so guys, when you have a pattern question, don't just jump into it thinking, oh, it's this. Make sure it's that type of a pattern. And the way you make sure is you don't just look at a connection between the first two numbers, you look for the same connection between the next two numbers. Now, if that is the same, then you're on the right track. Okay, so then it continues on page 46, 47, and 48, using the different rules to substitute in numbers and give me the values. So that's building you up to the algebra and the equations that we're going to be doing. All right. Okay, so page 49 concludes with that, and page 50 is the exercise 4.6 on patterns. Okay, guys, and what I'm going to stop at is we're going to stop on page 57. Okay, so the next section is functions and relations, which is 52, 53. So that's your flow diagrams. You're putting a value in, you do something in the machine, and it spits the value out. Okay, functions and relations. So be able to do those flow diagrams on page 54. And 55 is your input output, which is similar to the number patterns that we were doing. It works exactly in the same way. Follow the pattern, plug in the value for X, and work out the answer. Okay, guys, so the test will be up to page 57. This is the work that we have done in class, that we have gone over together, and that's what I'm going to test you on. The new work, once we are back, once we've gone over it, once you've asked your questions and I know that you guys can do it, then we're going to have a test on the geometry stuff and the next sections that we are doing. All right, guys, so in the next lessons, I'm going to continue with the work with it from the textbook. Good luck for your test on Friday, and I hope you guys do really well and you study hard. Cool, guys. Cheers.